Hi everyone, do you hear me? Okay. Thanks for joining this lecture. This is Jong-Seong Kug. I'm studying global climate change at POSTECH. Today, I'm going to talk about global climate change and climate tipping point. I wonder whether you have heard about the tipping point. The climate tipping point is one of the hardest issues these days. I'm going to introduce the concept of a climate tipping point and discuss why the climate tipping point is so important for our future life. Okay, let's start. You know, we are now having a hard time fighting with the coronavirus. However, this fighting is not the end. A stronger and tougher enemy is waiting for us. It is climate change. Let me firstly introduce the evidence of climate change, and later I will introduce the climate tipping point. Let's start this figure with this figure. This figure shows the global mean temperature in 2020. Because we don't have yet the 2021 data, so I just show 2020 data here. I have to explain the figure a little more. The color shows how much the 2020 temperature is higher or lower compared to the normal. The thick red color indicates record-breaking warm in 2020. The red is much warmer than average, and light red indicate warmer than average. Blue color here indicate colder than normal. You can see, except for a very small area, the most regions are red color, indicating that the 2020 temperature is much warmer than normal. In particular, the Siberian area was record-breaking warm. You may remember the news last year. The Siberia was about 40 degrees last summer. And also Korean Peninsula in East Asia was also much warmer than normal. So we can make a ranking from over how much is warmer from the past 140 years. The first ranking is 2016. Do you know why 2016 is number one? Please remember that there was a second largest El Nino in 2015-2016. Usually after El Nino year, a global mean temperature becomes warmer. So global warming plus El Nino makes the ranking number one of the 2016. The second warmest is last year. Is warmer than warmer 0.98. Then ranking 3 is 2019, 2 years ago. You can see the ranking first to 9th year are located between 2010 to 2020, suggesting we are now living in hottest period. You may find the somewhat special one, 1998. This is a somewhat exceptional. You know, this year, 1998 year is the largest El Nino year. So largest El Nino year make this ranking 11. So this ranking suggests that global mean temperature is mainly controlled by global warming and internal variability, such as El Nino. However, it is clear the global warming signal is more dominant. Okay, so This figure shows global mean temperature in the past 100 years. You can see sometimes the global warming is flattened and the global warming is steep. But it is clear temperature is gradually increasing. The temperature increase is about 1 degree for 100 years. Okay, so this is for the past 1,000 years. So actually there was very weak cooling trend before the Industrial Revolution, like this is a cooling trend. However, after Industrial Revolution, you can see a very rapid temperature increase. There is some noise. So, anyway, okay. So another evidence of the global climate change appeared in the Continental Glacial. These are pictures the same place from different timing. Hundreds of years ago, we can easily found a continental glacier on the top of the mountain. However, it disappeared and melted out. Okay. So reduction of continental glacier is directly linked to sea level rise. This is a sea level change. You can see sea level is continuously increasing. The more important thing is the increasing speed is faster and faster. This suggests the sea level rise is accelerating. Due to the sea level rise, the nuisance flooding is 3 to 4 times more frequent than it was 50 years ago. The sea level rise can be explained by 2 factors. One is ice melt, 50%, and the other is summer expansion, 50%. Among ice melt, the continental glacier explain about 6%. Greenland is 28%. Antarctica glacier melting is just 12%. But you have to know the most of fresh water reside in the Antarctic glacier. Recently, the Antarctica glacier begin to melt out, which is why sea level rise is accelerating. Okay, then let me give you a key. Please think about it. If the Antarctic glacier completely melt out, how much will global sea level rise? Okay, maybe some difficult question. So I may give 2 hints. So first hint, Antarctica glacier is only 2% of the total water of the Earth. Second hint, average depth of the global ocean is about 3,800 meters. Okay, then what's the answer? Please think about it. Okay, this is the answer. Because the total 2% of water is increased in the ocean mean depth will be increased. Then sea level rise is about 76 meters in calculation. The actual sea level rise is predicted as 6 meters to 70 meters. You have to remember, we only considered melting of glacier. As I said, there is also sea level rise due to summer expansion. If we consider summer expansion together, the sea level rise will be more severe than we expected. Then if there is a sea level rise, what happens? If the sea level rise is 2 meters, then Los Angeles, San Francisco will be submerged. At 6 meters, Shanghai and Edinburgh will be submerged. If the sea level rise is 80 meters, the right figure shows the map when the sea level rise is 80 meters. So you may compare this bottom figure. Then you can see the world map is completely different. Then you may ask a question whether such a dramatic climate change, sea level rise is really possible. We may check the path of our Earth. The figure shows the sea level during the last glacial maximum, 18,000 years ago. Sea level was 120 meters lower than present level. Please remember the temperature was 6 degrees lower than present time. The red color indicates it was continent. However, it's now ocean. The East Asia showed more dramatic change. There was no yellow sea here because the average depth of yellow sea is just 50 meters. At the time, there is no more Korean Peninsula, just part of the Eurasian continent. Also, Japan is not island anymore. It was connected to the continent. So this dramatic sea level change, the sea level rise, and it is possible depending on climate conditions. Another problem of climate change is increasing extreme weather and climate event. You can see the damage of the disaster is largely increasing. It's between 1980 to 99 and recent 20 years. Then the most damage is due to flooding, storm, extreme temperature, and drought, wildfire, which are related to global warming. So nowadays, wildfire burns longer and wider, extreme heat gets hotter, hurricane becomes more intense, drought condition persists. We were experiencing intensified heavy rainfall and frequent flooding. In spite of the warming trend, the winter storm is harder. Like this, extremes are getting worse under greenhouse warming. And why? What caused that? You know that? I think everybody knows the global warming is due to the increase in greenhouse gases. Actually, the greenhouse effect is very beneficial for human and our ecosystem. You know, the averaging temperature now is 15 degrees, but without the greenhouse effect, if we think there is no greenhouse effect, the Earth temperature will freezing level is a minus 18 degrees. So the greenhouse effect is increasing our Earth temperature by 33 degrees, making a good climate condition for our ecosystem. However, if greenhouse effect, its current greenhouse effect is further increased 10%, then we can expect global temperature will increase by about 3.3 degrees. Please remember the temperature increase during the last 100 years is only 1 degree, then we are worrying about. However, the temperature increase is 3.3. So you may understand how much small change is global in the global greenhouse effect can cause huge environmental change. Okay, so this figure show the changes in greenhouse gases. CO2 is dramatically increasing, and methane is also increasing after industrial revolution. Now CO2 concentration is more than 400 ppm. This shape of the graph is a kind of some hockey stick like pattern. It's a no change and abrupt increase. Actually, we have a similar figure. Change in world population. You can see world population is abruptly increased during the Industrial Revolution. The similarity between world population and greenhouse gases tell us that increasing greenhouse gases is anthropogenic. Okay, this is a recent observation. You can see the CO2 is continuously increasing, but it is interesting, the oxygen concentration is continuously decreasing. The decreasing oxygen is one clear evidence that CO2 increase is due to human activity. You know, CO2 increase is mostly due to fossil fuel burning and rainforest devastation. In this process, oxygen is consumed, so oxygen concentration is gradually decreasing. Okay, then I'm gonna briefly introduce the role of the climate feedback. You know, the feedback is a response or the forcing affect the course again. So there is a positive feedback and negative feedback. The positive feedback amplifies the forcing, and negative feedback attenuate it, the forcing. The final global warming is determined by competition between this positive feedback and negative feedback. Scientists found that in our climate system, the positive feedback is much bigger than negative feedback. So if we only consider CO2 radiate forcing, only radiation effect, then temperature increase will be just 1 degree, even though CO2 concentration is 800. However, owing to the positive feedback, global warming can be amplified. The temperature increase can be 3 degrees to 10 degrees, depending on the strength of the positive feedback. This is highly uncertain because we don't know much about our climate system. To quantify positive feedback of our climate system is a challenging problem in climate change research. Under the strong positive feedback, an abrupt climate change can take place and climate tipping point can take place. Okay, let's talk about the climate change tipping point. What is climate tipping point? You know, climate system initially respond gradually the climate forcing, but at a certain point, it dramatically responds when there is some very small forcing due to the strong nonlinear interaction. So at the climate tipping point, the climate system dramatically responds to even small forcing. Okay, let me explain some example. You may think about a cup of the table. If there is a cup, if you push a cup, okay, so if you push a cup slowly, the cup will move slowly. Okay, there is some gradual response of the climate. However, the push and push, then if this cup is located in the edge of the table, then a small push can fall down the cup. Very dramatic change. The edge of the table is the tipping point. So like this figure, we push the ball in this direction here, then the ball will move. If we stop the push, the ball will return to the original place. It's a reversible change. However, the ball is moved to this critical point and past this critical point, then ball will return to the different place and cannot go back to original place. Irreversible change. Such change are possible in our climate system. Mathematically, tipping point is very simple. In our Earth, it's a kind of it's a very complex mathematical set. There are many kind of solutions. Let's consider there is two solutions. Two solutions are possible. In our current world, it's one solution. But if you push global warming, the greenhouse gas increase, push this solution to the other solution. If this solution is moved to the other solution, then we may have a very different climate. There is very climate tipping point. During this moving from one solution to the other solution, there will be very abrupt climate change. There is a catastrophic change. Okay? Then, why the tipping point is so important? If our Earth passes the tipping point, our climate system will abruptly change, and this abrupt environmental change may collapse our social and economic system. You may hear about the Paris Agreement on climate change. Then most countries agreed to try reduction the CO2 emission. So that's why many countries declare it's a neutral of the climate emission. Net zero of the climate emission. The key word in the Paris Agreement is 2 degrees warming and 1.5 degrees. Most countries agree to limit temperature increase below 2 degrees. Then you should have a question. Why 2 degrees? Why not 3 degrees or 4 degrees? It is because some scientists want there is possibility for the tipping point if the temperature increases more than 2 degrees. That's why we pay attention to 2 degrees. Recently, there were many studies to warn that climate tipping point is in the near future if we don't stop the carbon emission. Then you may ask, is it really possible, climate tipping point? So, you know, the past is a mirror of the future. In the past, our Earth passed several tipping points already. A typical example is the Younger Dryas. Have you heard about Younger Dryas? About 1,400 years ago, Earth's climate began to shift from cold glacial to warm interglacial state. The temperature began to shift, so it's gradually increasing. However, during the temperature increase, it suddenly returned to the near ice age. The temperature drop is about 6 to 8 degrees in a few decades. Then this cold period is sustained for about 1,000 years. After these 1,000 years, the temperature recovery is more dramatic. The temperature abruptly increased 10 degrees during the 10 years. Remember that current our Earth has experienced just 1 degree warming in a century, but it was 10 degree warming for 10 degrees. You can see how much the climate system changed abruptly at that time. As well as younger dryas, there are many examples of the abrupt climate change. During the last integration, it's 125,000 years ago, the temperature is 1 degree warmer than pre-industrial. The temperature is, global mean temperature was very similar to present level. However, the sea level was 4 to 6 meters higher than current level. It has been reported there was rapid sea level change due to the abrupt collapse of the greenhouse glacier. Another example is a Dansgaard-Osuga event. In the last glacial period, 25 times abrupt climate change were repeated. Abrupt warming, abrupt cooling, abrupt warming, abrupt cooling. That interval is several thousand years. Okay, so the temperature change is about 5 degrees over the 30 to 40 years. Very dramatic change. So far, I showed there are several abrupt climate change in our Earth. Our question is, what caused this climate tipping point? Scientists suggest there are several potential processes to induce abrupt climate change. We call them tipping element. Most important tipping element is glacial process. You know that the glacier of the Antarctica and Greenland is result of the very long-term accumulation of the snowfall. You know, it's a snowfall is like a it's a small amount of accumulation. Then year and year, this snowfall is accumulate, then becomes glacier. Very slow process. However, when glacier melt out, its process is quite abrupt. Not just melting smoothly. It accompanies a collapse of the glacier. For example, there is a marine ice sheet instability. You know, the ice shelf is located over the ocean. So some part of the ice shelf is submerged in the ocean. You know that this ice is lighter than the water. So there is some balance between this buoyancy force here and the gravitational force. This is the weight of the glacier. Then as global warming goes on, then this marine ice shelf will melt out. Then this ice shelf is thinning and thinning. When the weight of overlying ice decreases, then if the ice melt causes thinning beyond some threshold, then ice sheet can maintain. Ice sheet can no longer be heavy enough to prevent the submarine ice below. Then ice shelf fall apart suddenly. There is a collapse of the ice shelf. There is another positive feedback in Greenland Glacier and Antarctic Glacier. So, you know, it's the melting reduce the height of the glacier. Then it exposes it to the higher temperature. Because if you think of the structure of temperature is higher in the some low atmosphere. I mean, so low altitude. Temperature is colder in the high altitude. Then this altitude of the ice is glacier becomes lower and lower. Then this glacier will be exposed to the higher temperature. Then the speed of the ice melting will be faster and faster, then accelerating. So this is a positive feedback. this positive feedback can accelerating the glacial melting. Okay, so I hope that you may remember this movie, the Day After Tomorrow. This movie showed some climate tipping point that its global climate is abruptly changed. Global warming is changed to the ice age. Actually, this movie is motivated by the younger dryas I explained. As the greenhouse glacier abruptly collapsed, if the greenhouse glacier is abruptly collapsed, a large amount of fresh water come into the Atlantic. So there's a large of fresh water forcing. Then ocean overturning circulation is a Atlantic meridional overturning circulation. This overturning circulation is very important for some northern hemisphere climate. Anyway, if the overturning circulation is suddenly reversed, then this warming is suddenly changed into the cold phase. This is one example that nonlinear interaction between glacial and ocean circulation can bring about the climate tipping point. Okay, then another climate tipping point I want to introduce, permafrost. Have you heard about the permafrost? The permafrost is like a ground, it's frozen, it's for a long time. So for the some inside of ground is frozen, but during summertime it's melt out. So there is a vegetation growth in the summertime like grasses and shrub. Okay, then you know the plant, the vegetation is made up of the carbon. Because vegetation die in winter due to the cold, it's a very cold climate, but does not decay due to the frozen. Then the carbon from the plant, its vegetation, is continuously accumulate in the ground. This is a very slow carbon accumulation. So the permafrost is a very large carbon stage. About 1,600 petagram is burned in the permafrost. Then 1,600 petagram, how much is it? You may compare some atmospheric carbon. This is about double of atmospheric carbon storage. Okay, so if this huge amount of the carbon is released, then there's some huge change of the climate. I mean, huge change of climate. Okay, so let's say if the permafrost begin to melt out, then CO2 and methane will be released into the atmosphere. Okay, so then this process can be very rapid. In particular, the methane is 25 times more effective greenhouse gases. If there is a same amount, then this methane is 25 times more powerful to warm up our Earth. So it's a large amount of methane release can cause abrupt climate change. Okay, so this is my last slide. Today, I introduce the climate tipping point, which will be called catastrophic change. Then, actually, this tipping point is like some scientifically interesting, but it's quite important for our life. Then the most critical question is when the climate tipping point will happen. There are two possibilities. our climate is very strongly stable, or our Earth is weakly stable now. If our climate is very stable, then tipping point is far from here, then we can save. Then maybe we can release more some CO2. However, if we are located in the weakly stable region, then tipping point is near future. Then depending on two positions, our policy should be quite different. However, unfortunately, our current knowledge of our climate system is so poor, too much limited to diagnose our current position from the climate tipping point. So this question, where we are, is the most important question and challenging question on global climate change. So we have to study this climate tipping point. Then I am working on this climate tipping point. Okay, that's it. So if you have any question, please leave your question in a chatting box. Then I will do my best to answer to your question. Do you have any question? No question? So actually, I mentioned it's a 2 degree in the Paris Agreement. I mentioned that some scientists point out is in the 2 degree, the climate tipping point can take place. But this is just a possibility. Frankly speaking, I don't agree. It's a 2 point. It's a not tipping point. Is in the 2 degree. But I don't know. I don't know. It's how much we have. But important thing is that we don't know. That's why we have to we have to act immediately. Okay, there's one question. Okay, so interglacial period, because the interglacial period is the temperature increases, temperature is higher than now. Then the sea level, then there is less glacier, and ocean temperature is warmer. Then sea level rise and some summer expansion can explain the more sea level rise. Okay. Also, in there was time the temperature was very similar, but at the time the Greenland glacier was collapsed. That's why the sea level rise. Okay, yeah, very good question. So it's a geoengineering and climate engineering is one of the hardest issue because we just reduce the CO2 emission. We have to spend too much money, right? So that's why geoengineering we are trying the geoengineering. But the problem is, I think that it can work, but we have to know there were some side effects of the geoengineering. If we have some CO2 sequestration, but we don't know what happened later then. So we have to try to understand our climate system very well. Okay, Is there any question? Yes, yes. This gas hydrate is like some the inside methane, then surrounded by ice. So sometimes they use this hydrate as energy. Okay, they are using. Likewise, there's a CO2. I mean, kind of some carbon emission. So there is like some one additional point of the global warming. Okay. Any other question? If no question, let me close this lecture. Thanks again for joining this lecture. Okay, if you have any question and comment, please send me email. Then I can communicate with you. Okay, thanks again. 끝내면 되는 거죠. Okay.